Hey makers, welcome back to the channel. Today we're checking out something I've been really excited to test, the Ortur R2 Smart Laser Engraver. Ortur calls this their Smart Laser Engraver, and it comes with a ton of cool features, plus the option to swap in different laser modules. I've been testing both the 20-watt blue diode module and the 1064 nanometer infrared module. And in this video, I'll walk you through the features, show you some engraving tests, share what I like, what I don't like, and ultimately whether this machine is worth it for your workshop. Let's get into it. Let's start with what Ortur says this machine can do. The R1 is marketed as a smart laser engraver. That means it comes with things like a sturdy all-metal frame for stability, Wi-Fi connectivity and app support, safety features like emergency stop and flame detection, and support for different laser modules so you can pick the right tool for the job. The 20-watt diode module is great for wood, acrylic, leather, and most hobby materials, while the 1064 nanometer infrared laser is designed for metals and plastics that diodes can't usually touch. Ortur also claims high engraving speeds up to 20,000 millimeters per minute, which is fast, plus a larger working area compared to earlier models. So on paper, it looks like a super versatile machine. I do want to mention that Ortur provided this machine for my review, but they have no control over the content of the video. They will not see the video before my viewers. Now, on to testing. So let's talk real-world performance. I started with the 20-watt blue diode module. First up, I tested it on some plywood, engraving patterns and doing a few deep cuts. The detail was crisp and it actually cut through 6mm plywood at up to 450 millimeters per minute, which was just a bit faster than the algo laser I tested recently. Here is a close-up of the two test cards side by side. On the left, we have the Ortur, which kind of peaked at 450. I was able to pop out the 500, but we'll say 450 was the top, as compared to about 400 over here on the algo. And here is a test card that was cut in 2.7mm plywood. The machine made nice cuts up to 700 millimeters a minute at 90% power. Next, I cut a couple of fun projects, including this personalized phone stand and a decorative Christmas ornament. The machine had no issues cutting this material, and the included knife blades were a welcome addition. You've got to get the plywood off the bottom of the machine to get a good cut. Up next on the test bench, image engraving. The first test involved engraving this T-Rex image on plywood. All the included setting recommendations for engraving in Lightburn list grayscale as the image mode. Diode lasers are uniquely well suited for this operating mode since they can react to power changes very quickly. This does, however, tend to create depth to the image in the wood and may not be the best for contrast. Here is the final result of that test. I tried another sample that Ortur sent along with the unit, which is kind of a fiberboard. This image was also engraved using the grayscale mode. Again, there is texture in the final result, but there isn't much contrast. I then wanted to see how well the camera worked in Lightburn. I was able to calibrate it, but as you can see from this example, which was engraved using the Jarvis image dithering mode, the placement was still off by a pretty decent amount. I'm too much of a perfectionist to rely on results like this. We'll talk more about the camera later on. Finally, on the wood front, I ran a speed versus power test grid on some plywood and then engraved this image. The results are much better, but as you can see, it can be tricky to hand place items in the machine for accurate results. Next, I tried leather and acrylic. The leather engraved and cut nicely, but if you're starting with dark leather, you won't get an abundance of contrast. I will say that if you venture into working with leather, make sure you have really good ventilation. The final test I ran with the 20-watt module was acrylic. I started with the piece of 8mm acrylic that they sent along for testing, and I put it on the knife blades. Acrylic is one of the most challenging materials to cut because the gases produced are very flammable. I used the recommended settings, and the machine cut through the material with ease, but it wasn't all roses. The flame detectors worked well, but the behavior is a bit odd. The machine will pause at times and then start working again. Occasionally, you'll get a message on the screen which asks if you'd like to proceed. I let this job finish, but you can see that the bottom of the piece suffered from all of the flames. Next, I tried cutting a thinner piece of 5 mm thick black acrylic, and the flame situation was the same. Now, I've cut a lot of acrylic with my CO2 laser, and I always use a honeycomb bed. So I decided to grab a small honeycomb bed that I bought for another diode laser and use that in the R2. Once there was enough space beneath the acrylic to let the gas escape without being ignited, I was able to cut the acrylic just fine. Next, I reconfigured the machine for the 1064 nanometer infrared module. This swap requires cutting all of the zip ties that secure the air assist tube and the wiring for the laser module and the flame detector located beneath the X gantry. The IR module is then wired in and the wiring is zip tied back in place. I ran the tests on the items included in the test kit Ortur provided, and the engravings were sharp and detailed. IR lasers have a much smaller dot size than blue laser diodes, so that is to be expected. I engraved this keychain, which came out pretty nicely, as well as this business card. The detail is really incredible. My last test was a few dog tags, which will go to my grandpups the next time I see them. Alright, let's break down the pros and cons. I'm not going to put graphics up on this review because I have a lot to discuss here. We'll start with the pros. First, it's a modular system. You can swap between the blue diode and the infrared modules depending on your project, although it is a bit involved and you may not want to do this terribly often. Next, the safety features. The flame detection is a nice addition. I like that Ortur takes that seriously. It's also a very quick setup. It is almost plug and play. You do have to attach the hose port on the back, but other than that, you're just connecting power data and air lines, and then the machine is ready for use. The large parameter guides are a nice addition. It's always great to have a starting point when trying new materials or a new machine. Finally, it's competitively priced. I currently see that the 20-watt kit runs $7.99 US, which is less expensive than some of the competitors out there. And now for the cons. We'll start with the wireless and app features. The unit only supports 2.4 GHz networks. Fortunately, my router has a secondary access point for IoT devices, and I was able to set this one to 2.4 GHz only. I was never able to get this device to connect on my Android phone. I did use an iPad and the iOS app, and I was able to successfully connect. Ortur is still working on the app. In the few weeks of testing, there were 3 revisions to the app to get basic features working. The first time I got the device connected and the camera calibrated, the framing was off by around 20 millimeters in the y-axis. Once they got that fixed, and a few other issues I found, I was able to engrave this image via the iPad, but the placement still isn't as accurate as I'd like. I'm not going to go into the other features of the app because they'll probably be very different by the time this video is published. Next, the camera. I just mentioned how I ran into issues in the app with the camera calibration. I also had issues in Lightburn. One thing that you need to know about camera calibration for lasers is that you have to recalibrate the camera every time you change the thickness of the item you're engraving or cutting. When I tried to get the camera to calibrate in Lightburn a second time, I simply could not get it to calibrate. I haven't run into this issue before with any other camera-equipped lasers that I've tested. Next, homing and reliability. When I was testing the IR module, I decided to engrave the dog tags that I showed you earlier. Since the camera, even if it is working well, isn't a great option for precise placement, I chose to make an outline on the dog tag and engrave it into a card taped to the bottom of the machine. I then placed the dog tag in the outline and ran the job. This does take quite a bit of setup, but I figured it would be the best way for accurate results. Even after homing the machine after engraving the outline, the engrave was quite a bit off. Here is the result of this first test. I then decided to try repeating just the homing and outline test. Here we have the machine engraving the outline, then running a homing cycle, and engraving a second time. You can see the results are off just a bit. I then ran a third cycle and the outline jumped by almost 2 millimeters. Most diode lasers I've tested lock the stepper motors when the machine is powered on. This one does not, and in fact, there is no way to control the motion system from the display unless you are running a stored job. So you either move it by hand or use Lightburn. It should be able to home and have repeatable results. Next, we'll talk about the display and control panel. The display is nice, bright, and adjustable, but it's really underutilized. When a job is running, it just displays working. It would be nice if it would show some status information. The file list is also frustrating. It just shows long file names from the storage card with no picture, and only files sent via the app. I can't imagine running a save job from this menu. The controls available to you once you select a stored job should be available all the time from the main menu screen. Next, onto the motion system. The Y gantry motion is really rough. The cabling and air assist hose on the left side of the machine really seem to bind up, and this might be part of the problem with reliable positioning. Let me show you what I mean. You can feel a considerable amount of resistance when manually moving the gantry along the Y-axis. There seem to be a number of binding spots. As you near the limit switch, the cabling is so compressed that the gantry will not stay in the 0 position. You probably heard the grinding sounds in the earlier homing demonstration. I believe this is the belt skipping teeth as it encounters this resistance. The compressed cables generate enough force to move the gantry back away from the Y-limit switch. And finally, the air assist pump is completely manual. That was fine 2 or 3 years ago, but you should be able to get a little more these days. Both the Creality and Algo Laser machines I recently tested use the same style pump, but they both have integrated light burn control. The Algo Laser even has a manual control that lets you adjust the pump output if you're running a standalone job. Even the Atom Stack laser I tested several years ago had a dial on the front of the pump for control. Okay, I think I've covered it all. This machine started out with a lot of promise and I was excited to see what it could do. Is it hopeless? Well, no. The app is being worked on, and there are probably some upgrades to the firmware that will expand the capability of the display. For simple cutting and engraving jobs where repeatability isn't an issue, the machine works fine. However, if you need precise positioning, this machine has some problems that software isn't going to solve. What do you think? Anyone out there own the R2? Am I off the mark, or maybe I got a bad unit? I'd love to hear your take. If you found this review helpful, please take a moment to hit the like button, subscribe to the channel, and hit the notification bell so you get notifications when I drop new content. As always, I enjoy the time that we get to spend together here on the channel. Let's keep on learning, burning, printing, and growing together. Take care, everyone.